Hello everyone, today we continue our bow and arrow tutorial part 3. We will attach the bow to the character hand. Now go to third person character, go to skeletal mesh and open skeleton 3, character, bone or hierarchy. To show the bone, slow the camera speed a little bit. For spine 3 bone, create a new socket, add socket, call it bow socket, add preview asset, our bow, adjust it to rotate and move the location. Now create a new socket, add socket, name it left hand socket, and one more socket on right hand, call it right hand socket. Create a bow on the left hand socket, add preview asset, choose bow, and for the right hand socket, add preview asset, choose the arrow, go to preview scene, choose specific animation and choose the aim animation. Adjust our preview mesh, adjust our arrow, rotate it, and now it stays in the correct place. Go to third person character, click on mesh, add scene component, name it bow socket, add a child actor, and add other scene component, name it left hand socket, and one more scene component for right hand socket. On right hand socket, set parent socket to right hand socket, and left hand socket set parent socket to left hand socket, and bow socket with bow socket. Now create new actor, bow blueprint, BP bow, add possible mesh. We use possible mesh because our bow is a skeleton mesh and we need to change the position of the bone of the string. Only possible mesh can change it. Drag our bow to skeleton mesh and create new blueprint interface. Call it BPI bow. Create a new function, name it set string is Titan. Create new variable input Titan and another one, call it string location. Set it to vector. Go to bow blueprint, go to set class setting, add blueprint interface that we just created. Promote Titan to variable and promote the string location to variable too. For the bow skeleton mesh, we have this string bone that we call the function to move its location. Now on eventic, if it is tightened yet possible mesh, set bone location by name. The bone name is string and use our string location. And if it is false, set the location to 0, 0, 0. Now go to our third person character. On child actor class, apply our bow blueprint. When we hit right mouse, then we equip the bow. We have to go to our animation montage. Create a notify at the point where the character grabs the bow. Add notify, montage notify. On notify begin, attach our bow to the left hand socket. Set the location to snap to target. Rotation snap to target. And scale keep blur. And when we release the bow, go to disarm animation montage. Create notify when the character put the bow back moment. On notify begin, attach component to component, attach it to bow socket. Location snap to target, rotation snap to target, and scale keep blur. Let's playtest it. The shadow caused by the string.
Oh hell no, man! What the fuck, man?
To fix the shadow problem, we have to go to bow blueprint, and when we set the location by name, the titan is failed. Set the bone space to component space. The location of the string of the bow will stay relative to the bow, not in the world space. Now I will show you how to pull the string. Go to third person character, create new function, call it pull string. Create new variable to input, name it titan. If titan is true, get child actor and get child actor target. Set string is titan to true. Get mesh and get socket location. Socket name is right hand socket. If titan is false, set string is titan to false. String location is 0. Create eventic. Create new variable. Call it pull. If the character aim and pull, call function pull string. Set titan aim and pull. Go to aim bow. Before we aim, we not yet pull the string, so set pull to false. When we play draw montage, create notify, montage notify, and notify name is pull. On notify begin, if the name equal pull is true, set pull to true. When we get input jump, before play the animation montage, set pull to false. And after we play the montage, if aim is true, set pull to true. Let's playtest it. Now the character can pull the string. And when we release the bow string also release tool. To attach the arrow to the character bow, go to arrow and create blueprint actor, call it BP arrow. Add a static mesh and use our arrow to the static mesh. Set the collision to custom and click on ignore all. Go to third person character, create a new custom event, name it arrow spawn. Add new variable, name it arrow, and variable type, set it to BP arrow object reference. Allow to spawn when the arrow is not valid. Call spawn actor from class. Choose class is blueprint arrow, get mesh, and get relative transform. Connect it to spawn transform. After we spawn it, set it to arrow variable and get root component of the arrow that we just spawned. Attach it to right hand socket. Location rule, set it to snap to target. Rotation, snap it to target. And scale rule, set it to relative. To spawn the arrow, go to custom event, aim bow, and when we draw the arrow, create a new notify in the animation montage. The moment when the character takes the bow from her hand. Add notify, montage notify, and on notify begin. If the pull is false, check if the aim is true. If it's true, we will spawn the arrow. And when we release the right mouse, this means that we don't shoot the arrow, and we will destroy the arrow if the arrow is valid. And when we left hand click, get orient rotation to movement, check if it is false, and if the arrow is valid, we will destroy the arrow, because we shoot this arrow and it have to disappear. Now go to jump input action. When we dive forward, we have to destroy the arrow too. And after dive forward complete, if the character is still aiming, we have to spawn the arrow back. Now the character about to spawn the arrow. We have the orient rotation bug. To fix it, go to standing draw arrow montage. After we play it, we should check aim is true before we set orient rotation to movement to fall. We have to create character control rig. Go to character file, open mannequin file, open rigs, create control rig, choose control rig, create, name it CR leg IK, open it, click on rig hierarchy, import hierarchy, choose SKM menu, OK, select root, create new control, name it foot L, choose the shape to box 6, set the scale to 2, move the control to right, and set its current location to 16. Copy the location, pass it in initial location, duplicate control foot L, name it foot R, and set the initial location to -16. Compile, create new control, name it pelvis, choose the color to pink color, set scale to 3, choose the shape to box 6, move the pelvis control to the pelvis, set it to 3.7 and Z scale to 2. Copy the current location and pass it in the initial location. Compile. Now create full body IT. Choose root bone to pelvis. Create new effector. Select the bone to foot L. Get transformed from control. Choose foot L. Connect translation to translation. Set rotation alpha to 0. Add new effector. Choose bone to foot off. Get control foot off. Connect translation to translation. Set rotation alpha to 0. Add bone setting. Set bone to pelvis. Use prefer angle. Tick it. Prefer angle equal to 1, y1, z1. Open the setting. Root behavior. Choose pin to input. And now compile. Test it. Yes, now the control able to control the tractor leg. Go to my blueprint. Create new variable. Call it left foot position and variable type. Set it to vector. Duplicate it. Call it right foot position. Add new variable. Call it start trace. Set variable type to boolean. Create a branch. If start trace is true, we will trace the foot position, and if start trace is false, we don't do anything. Now create a sequence. Get transform control. Type control. Name choose pelvis. And get transform bone. Name choose pelvis bone. Set transform bone. Choose pelvis. Expand transform pin. Connect translation to translation. Rotation to rotation, and scale 3D of the bone to scale 3D. Then create a new function. Set foot control. This function will convert the foot world position to be the relative position of the mannequin. On entry, add new input. Name it foot location. Choose vector. Add new variable. Call it foot control. Choose item. Expand the foot control pin. From our item, get foot control. Get transform. Create a mat function. Set our transform to input transform. For our foot location, convert it from world to vector. Subtract it by z equal to 200 and create a sphere trace by object types. Select our global location to start and result to add location. And for hit normal, if connect hit to condition. If hit is true, we use this target for the aim mat, and if it is false, we use vector z equal to 1. Select time to direction. Our axis, set x to 0 and z to 1. Now create set transform bone. Connect our item to the item of set transform bone. Connect our aim mat rotation to set transform bone rotation. Connect global location to set transform bone translation. And now we create a draw transform. And for translation, we use the hit location from sphere trace by object type. For thickness, use 5 and connect it to return execute context. Go back to rig graph and get left foot position and call our function set foot control. Choose our foot control. Type is control. Name foot L. And get right foot position. Call our function set foot control. Type is control. Select name foot all. Connect it. So now we already set up our control rig. We able to receive the leg position from the workspace. And for the next video, we will create the leg actor that able to create the foot position of the foot motion. And we use this position to control our control rig. For the next video, we will make our character about to turn in place when she aims the arrow. If you have any question, please leave it in the comment section below, and please subscribe to my YouTube channel. It really means a lot to me, and thank you very much for watching. See you in the next video.